All right, we'll be doing questions 4, 5, and 6 from our third assignment of 3.7 and 3.8, graphing rational functions. Looking at function p of x here, we need to factor. We see that there is a 3 in common, so we can factor out a 3. We're left with x squared minus 4. In the denominator, we see there is a 4 in common and an x, so we can factor out a 4x. Factor that out, we're left with an x minus 2. X squared minus 4 factors to x plus 2 times x minus 2. So we factored. However, we look at this right here and see we can cancel some things. So x minus 2 cancels with x minus 2, which means x plus 2 is a whole. So at x plus 2, we'll put a circle down here to remind us that there is a hole in the graph. We have our final form of our function after we canceled. We can now find zeros. Zeros are values that make the numerator equal 0. So that would be negative 2, just multiplicity 1. So we'll put a dot on the x-axis at negative 2. Vertical asymptotes come from values that make the denominator equal 0, which is 0, just multiplicity 1. So the graphs will be in opposite directions at that asymptote. So we found zeros, talked about vertical asymptotes. The easiest way to look at horizontal or slant, we compare the degree of the numerator to the degree of the denominator. If we come all the way back to the beginning, before we canceled, we have a degree of the numerator is 2, degree of the denominator is 2. They're the same, and so you look at the leading coefficients. You can also look at the canceled version. The degree of the numerator is 1, the degree of the denominator is 1. So that also works. They're equal, but we look at the degree, the leading coefficients, the ratio of the leading coefficients. So we end up with 3 over 4. And so we put our horizontal asymptote at y equals 3/4. I did my best to estimate that on the graph. And then we think of y-intercepts. Well, if we come back, let's erase some things here. If we come back to our final or our reduced form here, we can't put 0 into the denominator because it would be undefined. So there are no y-intercepts to be concerned about, and we took care of that. There's one vertical asymptote, so we'll think about the left and the right here. And we want a graph. So once again, we have an option that uses the vertical asymptote, gets closer and closer to the horizontal asymptote, the orange one, and then the green one at the vertical asymptote goes through this point and comes closer and closer to the horizontal asymptote, which obviously, hopefully, you see that the orange one does not work, and it has to be the green section. Now we can use our vertical asymptote. We can do a couple things here. So before we talk about the vertical asymptote, we could think the same thing over here. Let's go yellow. We could have this one, this yellow section, or we could have this black section. Well, we definitely know it is the yellow section because the black section would have to pass through the x-axis, and we don't have an x-intercept. So it's not the black section, has to be the yellow section. So let's go ahead and make that yellow section orange to match the other side. So it looks like that. However, we have this little hole down here that we have to take care of. So we're going to come and we're going to erase our graph at 2 and put in an open circle there to show that we have a hole in the graph. Oh, that wasn't orange, that was green. So I'll change this one to green, to orange. All right, so there's the graph for number 4. Moving on to number 5. We need to start by factoring. In the numerator, we see that there is an x in each term, so we factor out an x. and we're left with x squared minus 2x minus 3. In the denominator, we can factor, and we have an x minus 3 times an x minus 2. Right here, back to the numerator, this can factor further to x minus 3 times x minus 1. So we factored, however, we can also cancel. So x minus 3 cancels with x minus 3, which means we have a hole at x equals 3. So at x equals 3, let's put a hole down here at the bottom to remind us. And then we can write our simplified version. With that simplified version, we can use the numerator. Values that make the numerator 0 are the zeros, so that's 0 and negative 1. So we see we have that written here, 0 and negative 1. So we'll put a hole at 0 and a hole at negative 1. Sorry, not a hole, a 0 at 0 and at negative 1. Vertical asymptote values that make the denominator equal 0, which is at x equals 2. So x equals 2, notice we put a vertical asymptote at x equals 2. So we have that there. And then we now need to decide about horizontal or slant asymptote. We look at the degree of the numerator compared to the degree of the denominator. Easiest to go back to the original 3 and 2. And so the degree of the numerator is bigger, so we're going to have to do long division. So it's a slant asymptote. So let's zoom in and look at our long division. That's the most we can zoom in. So what times x squared gives me x cubed? Well, that's x. Right, so we have that x there. And then we multiply. So x times this whole thing gives us x cubed minus 5x squared plus 6. And then we subtract. So x cubed minus x cubed is 0. Negative 2x squared minus a negative is positive. So plus 5x squared is 3x squared. Negative 3x minus 6x is negative 9x. And then we bring down. Now we have to think again. Let's go with green here. How many times does x squared go into 3x squared? And that answer is 3. And now we could multiply and subtract, but technically that's all we need. There is our slant asymptote. Y equals x plus 3 is the slant asymptote. So zooming back out, we can graph y equals x plus 3, which has a y-intercept at 3, slope of 1. So there's our slant asymptote. We can find the y-intercept, plug 0 in. So that's 0 times x, 0 plus 1 over 0 minus 2, which is 0 over negative 2. So we already had that our y-intercept was 0. And now we think through our graph. Again, we have one asymptote, so we have a left side of the asymptote, and we have a right side of the asymptote. And so we're going to think through that. Hopefully we're getting better at this. This one should be pretty easy to see. We have to hit these two x-intercepts. Pretty sure the only way we can do that is to have our function start here at our vertical asymptote. It's going to come our multiplicity odds, so go through that one, go back through that one, and get closer and closer to the slant asymptote. And honestly, we could kind of know it's not going to be this one that I'm drawing, because that would give us an x-intercept, and there is not an x-intercept there. And so we don't have a lot of room here. So let's say we continued our vertical asymptote a bit, continued the slant asymptote, and the other section of our graph would be up here, which also, just kind of for double checking, that matches the idea of this asymptote here. Came from x equals 2, which was multiplicity 1. which is odd, so they have to go in opposite directions. And then lastly, I see this little orange circle to remind me that there's a hole in the graph at 3. So I'm going to come up here on my graph. I'm going to erase at 3 and put an open circle. And there is the graph for number 5. And finally, number 6. We need to factor r of x. So the numerator, we see there's an x squared in common, so we can factor in an x squared. We're left with x squared minus 7. In the denominator, we can factor out an x squared. All right? So working with what we have now, x squared minus 7, haven't talked about much, but this is not a difference of squares, but we're in pre-calc now. The perfect square of 7 is just the square root of 7, so we can factor this to x plus the square root of 7 and x minus the square root of 7, which I believe the square root of 7 is approximately 2.6, so we can use that when we do our graphing. The denominator, nothing else can factor, so we factored. We check for holes. Well, x squared cancels with x squared, so there will be a hole at x equals 0. Hole at x equals 0, so let's put an open circle down here, or if you wanted to, you can put one there right on 0, as long as you remember what it's there for. All right, now looking at our final simplified function here, we have x plus root 7 times x minus root 7 over x minus 1. We know that zeros come from values that make the numerator 0, and that would be at positive root 7 and negative root 7. Oh, there I did write negative 2.6 and 2.6 there, so let's put zeros at approximately negative 2.6 and positive 2.6. Vertical asymptotes occur when the denominator is equal to 0, which would be 1. So we have a vertical asymptote at x equals 1, which you see drawn there already. And then, so we took care of zeros, vertical asymptotes. Now we have to decide between a horizontal and slant asymptote. So we look at the degree of the numerator compared to the degree of the denominator. Easiest way in this case is to look way back at the beginning. This was a 4 in the numerator and a degree of 3 in the denominator, which means we have a slant asymptote. We need to divide. So here's our division problem. Notice I did put I put a 0x cubed, a 0x, and a 0 to help with our placeholders. And we think x cubed times what gives me x to the 4th? Well, that's x. Then we multiply. X times this gives me x to the 4th minus x cubed. We then subtract, so x to the 4th minus x to the 4th is 0 x to the 4th, so we don't need to put that there. 0 x cubed minus negative x cubed is a positive x cubed. Bring down the negative 7x squared. Then we think, let's go to pink, we think x cubed times what gives me x cubed, and that's 1. So we have this 1 here, and technically we could keep going, but we can stop here because our slant asymptote will be y equals x plus 1 as I have written here. And so we're going to graph y equals x plus 1 as our slant asymptote, which means we started our y-intercept of 1 and have a slope of 1, so 1 over 1. So there's our slant asymptote. So we did that. Y-intercept and other helpful points. Y-intercept, plug in 0 for x. So over here we would have 0 plus root 7 times 0 minus root 7 over 0 minus 1. Well, that's root 7 times negative root 7, which is negative root 49, or just negative 7 over negative 1. And so we have a y-intercept of negative 7 over negative 1, which is 7. Way up here. And so that should give us a good indication of what our graph looks like. Vertical asymptote has to go through that 7 there, through our 0, get closer and closer to our slant asymptote. For a couple different reasons, we know the part on the right side has to be down because we'll talk about it. Our vertical asymptote came from, got a lot of writing over here. Let's erase some things. Didn't want to erase that much. There we go. So right here, x equals 1, multiplicity 1, which is odd, so they go in opposite directions. And so since to the left of the asymptote was up, to the right needs to be down. So it needs to come up, it needs to go through this point, which is the other reason it has to be on the lower part, and then get closer and closer to the slant asymptote. And there is the graph for number 6.